Okay, we have here to another integral on the board. We've got the integral of cosine of x, sine squared x, 8 sine x plus 15 dx. Okay, this is a problem that came up in a previous video where I noticed that we had kind of a harder version of this. And in that video, I mentioned there's an easier version and a harder version. Well, this is going to be the easier version. It's going to go a lot quicker than that other video. But if you want to check out the harder version, I'll provide a link in the description. Okay, to get started with this, the nice thing we have going on here with having a bunch of sines in the denominator is the derivative of sine is cosine, and we have that in the numerator. So I think a u substitution is going to work really well here. I'm just going to call my u equal to sine x, and then du is going to be the numerator, which is cosine x dx. And then we'll just go ahead with this substitution. So we'll have here du, and the denominator is going to turn into u squared plus 8u plus 15. But now if it didn't stick out right away, it's become clear that the denominator is going to be factorable, and that's what I'm going to do. So when we rewrite this, I'm going to take this and we can factor this as u plus 3 times u plus 5. And of course, the way I want to handle this, partial fractions. Okay, now we have our partial fractions set up here where I've just split up our denominator into two parts. We need to find these unknown values, a and b. And for this, I'm going to use the cover-up method. We want to just start with here, what's going to make this part u plus 3 0? Well, minus 3 will make it 0. I'll plug that in here, cover up this piece. When we plug this in here, we end up with 5 minus 3 or 2. So the fraction's 1 over 2 or 1/2. And then I'll do the exact same thing here. What's going to make this piece 0? Well, it's going to be minus 5. So we'll take the minus 5, plug it here, cover up this part so I'm not dividing by 0. This becomes minus 2, 1 over minus 2, or minus 1/2. So now that we have our a and b values, we can go ahead and split this into two integrals. So the first one will have now our a value is 1/2 over u plus 3 du, and then our second integral, we use this b value minus 1/2 over u plus 5. Well, these are two really easy integrals. So for the first one, we'll take the 1/2 out front. You know, we could bring these out front of the integral. It doesn't really matter. And then for this, we're just going to have natural log absolute value u plus 3. And then really similar for the second one, we have our minus 1/2 out front, natural log u plus 5. And then with the same coefficient up front, I can actually factor 1/2 out. And then because we're subtracting these, I can, by properties of the logarithm, I can put this in one expression as a fraction, so we can divide by the u plus 5 and write it like this. And then to finish this off, I just need to back substitute with my u equals sine x right here. So for our final solution, we're going to have 1/2 natural log. Then we'll have sine x plus 3 over sine x plus 5, absolute value plus c, and that's it. So that's it. We'll stop it there. Thanks everyone for watching. Have a great day.